Hello, my name is Mohamed Ahmed, and I'm a civil engineering student studying at the City College of New York. And today we will be talking about steel and iron as raw materials, a little bit about their history and their processes. Although about 5% of the Earth's crust is composed of iron, it is rarely found in its metallic form in nature. Iron is always combined with oxygen, and it is usually found in rock, gravel, sand, clay, and mud. And in this form, it is mined as iron ore. Iron and steel making revolves around the extraction of iron from these ores, combining it with carbon and other elements, and then forming it into shapes. Pure iron is easily shaped, relatively weak and soft. However, raw iron is what is used usually in construction nowadays, especially in the Eiffel Tower, for example. A little history about iron. Iron was discovered from about 4,000 years ago in Egypt, and as time went along, it was found in other places around the earth. For example, China, which is about 2,700 years ago. It is known that high-quality steel was made in ancient Syria, but these processes were lost through time. Until this, a man named Benjamin Huntsman in the 1730s created an invention named the crucible process, which permitted the melting of blister steel into a homogeneous mass, which basically produced steel in the modern sense. Although his invention created high-quality steel, the process was quite labor-intensive and yielded only small amounts of steel. Now we will discuss some of the processes in iron and steel making. One method of mining iron ore is from receiving it from underground, and one famous iron ore region is Lake Superior. Most ore mined in Lake Superior are tactonite, which is really close to the surface, and to mine this ore, superheated flames must be used to drill holes. After the ore has been mined, it then goes through a process of beneficiation. Beneficiation has two subparts. One is grinding and concentrating them to increase the iron content. The second is agglomeration, which increases the ore particles to a size suitable to blast furnace them. There are two forms of agglomeration, one which is called pelletizing and the other one which is called sintering. One form of pelletizing is through magnetic separation. This is where magnetic taconite is crushed into fine powder, and then the powder is passed through a magnetic separator which removes the iron particles. Then the iron powder goes to a balling drum where it is mixed with coal dust and a binder material to make pellets which have 60% of iron content. Another form of agglomeration is sintering, which is a process by which iron ore dust is fused with coke and fluxes into a clinker-like product containing 52% to 65% iron. And throughout the process of iron and steel making, a multitude of air, oxygen, and water is used. For every 1 ton of iron, it takes 4 tons of air to make. And for every 1 ton of raw steel produced, it takes 35,000 gallons of water. Overall, we discussed the history and processes of iron and steel making. We dove into iron ore and its process, and we talked about the implications of air, oxygen, and water in iron and steel making.